this is the 3-bit point-to-point RTL transfer. So there are registers A, B, and C that'll be shown in red here. This is the input where they can use to get numbers into register A. And these are the control signals. You can write A to B, A to C, B to A, B to C, or C to A and C to B. And switch 11 is used to get the input into register A, like that. Now let's transfer register A to register B and look at the delay. There it is. And that time it didn't pick up a delay. Let's try it again. And try one more time. Okay, there's the delay of 500 picoseconds. Alright, this is the 3-bit bus RTL transfer system with 3 3-bit registers. So I've got the 3 registers shown in the red LEDs here, and the bus will be shown in green here. I've got my input switches, and then my control signals. These switches are for writing from the registers to the bus. These are for reading from the bus to a register, and this is for putting the input into register A, just so we can get a number in. So I'll set that high, set the input to 5, hit the clock, and that'll write it to register A. Now we can write the register A to the bus and take a look at the delay. There it is. And in this case, it didn't pick up a delay. Let me try it again. Oh, hang on. I'll pick up 2 button presses. Here we go. Yeah, so it's about a 500 picosecond delay. Sometimes the oscilloscope doesn't register that. Hang on. Okay, now we'll demonstrate the delay it takes for the bus to write to a register. So we'll write 5 from the bus to register C. There it is. And let's look at the delay on that. Oh, I think I picked up 2 button presses again. There we go. So that is 1 nanosecond. We're going to be reading and writing to and from the SRAM using registers. So these 4 switches are the address of the RAM, and these 4 switches are the data. I've got the registers in green over here. So, and when you write to the RAM, it takes it from the register. So I'll show you what I mean. This key here will write the data into a register here. So we've got 0110, and if we press key 3, it'll write it to this address on the RAM. So we'll write that to address 0, and then we'll write 7 to address 1. But before we do that, we have to load it into the registers there. Right. And then we'll write 1101 to address 3 or 2. Load that into the registers and then put it in the RAM. And one more, we'll put 0 and 3. Okay, now I'm going to load the... Oh, and before we switch to reading it, there's no way to directly measure the delay for the write, so we estimated it based on the data sheet. The maximum write time for this chip is 15 nanoseconds, so you won't see more than that. We can't directly measure the delay though, because there's no indicator on the RAM to say when it's done writing. So let me program it for reading now. Okay, yeah, so as you can see, it'll show the contents of the RAM in red here, but it won't write it to the registers until I hit key 0. So as you can see, it's exactly what we wrote in earlier. If I push this button, then it'll write it from the RAM into the registers. And this one we can measure the delay on, so let me demonstrate that. And here the delay is, well, it didn't pick up a delay this time. Let me try it again. Let's try this.
There we go. So that is about 1 nanosecond.